Wait for a few more people to get in. All right, morning everyone, and welcome to the July 30th Alta webinar entitled U.S. Liming Analysis of Lime U.S. Liming Analysis of Lime Recommendation Systems. Today, Dr. John Jones, who I'm excited to say is now from the University of Illinois, will be joining us to share on some of his perspective as part of the first liming project, and then also to share some of his anticipated research that he will do now that he's in Illinois. So with that, John, I'm going to hand it over to you.
Great, thanks, Corey. I will go ahead and share my screen. All right, can I get a thumbs up that this is in presentation mode? All right, awesome. Thanks, Corey. All right, well, I appreciate the invitation to talk today. I'm calling from my soon-to-be hold office in Madison, Wisconsin, but we'll actually be moving to Illinois in 2 days, and then starting at the University of Illinois on the 16th of August. So excited to get down as the soil fertility specialist in the state and engage with many of you on the call as well. So when Corey sent me an email to talk about some topics and potential things to cover for an Alta webinar, we talked about state liming recommendations and some work that's being done within the first project, looking at lime recommendation comparisons, and then where do we go kind of as a next step to up our game and collaborate a little more widely regarding lime recommendations and soil acidity management. I will say the picture, what we see many times in the fall of lime piles around fields. I'm always happy that all the times I ask my wife to grab pictures when we're driving by lime piles that we drive around in the country. These now pay off with backgrounds for slides. So a quick overview of the first fertilizer recommendation support tool project. You'll see the URL there. I know there's been Alta presentations and webinars this summer already from FIRST members and collaborators. And so just a quick summary slide of kind of a summary of what FIRST has done on the P&K side, but looking to bring together scientists, industry practitioners, governmental agencies, and beyond to look at phosphorus and potassium soil test-based recommendations around the U.S. And then recently, I should say a few years ago, but relatively recently, there was an interest in looking at soil test-based lime recommendations and lime recommendations in general. Because really, when we think about soil test-based recommendations and the status of them around many states in the U.S. and North Central region, a lot of people and investigators and agronomists are looking at what's the next step, and to update a lot of these recommendations, and simply how can we advance the science behind it, which is just as important, and make the decision-making process a little bit more simple and streamlined and supported for farmers and agronomists. So the Lime group was started by Dr. Robert Miller. Bob's been active member and engaged with Alta and has spoken here before. The first year really of the project, we really just had monthly meetings trying to get a common knowledge base of soil acidity and lime management. And it was really fun to do those meetings and speak with people around the country who have been actively doing research in soil pH and liming. And those presentations are on the FIRST website, soiltestfirst.org/lime. And we really just kind of covered some basics: soil pH, soil acidity, soil pH methods, buffer pH methods, incubation methods that I'll get into a little bit later, and then some field calibration work as well. So the question kind of came about. We've been addressing phosphorus and potassium recommendations and considerations around the U.S. Why is integrating liming into that a pretty logical choice? Well, certainly when we think about the relative size of a ag lime purchase or input into a partial budget, can be relatively small or large, depending on what your objective is going to be for a given cropping system. A lot of these prices change locally. We know that the cost for liming itself sometimes is really lying in the hauling of the product or the lime, depending on your proximity to a quarry or a producer. My neighbor up here in Wisconsin, we set together a liming program last fall, and it was around $34 a ton for application and product, and that ended up being about 80 acres per ton at a little under 2.5 ton rate. So there certainly is a cost and a cost that's associated with liming that we think is pretty considerable, but it's certainly not always an annual decision. And so all of this, I'm talking mostly about the economics here compared to the P&K recommendations, but really there's some kind of agronomic challenges that I'll touch on a little bit later. So again, more background of why we're looking at liming recommendations. There are certain parts of the country that acid soils are popping up where they weren't necessarily expected to, especially when you get into the northern Great Plains. We're looking at no-till soils that are still dealing with an ammonia-based nitrogen fertilizer source and some other cropping system practices that have led to surface soil acidification. I was involved in putting together the 2020 North American Soil Test Summary with the Fertilizer Institute and Fertilizer Canada. The soil test summary was started by the International Plant Nutrition Institute in 2001. And I'll show a little bit of information from the soil test summary here, but just kind of getting some background into what I'll cover today with the survey results. We see these fluctuations and again, these are our soil pH ranges across the whole conterminous United States. So in 2001 up to the survey in 2020, and it's kind of bracketed into certain ranges in soil pH by half a pH unit. And certainly we see fluctuation, but not real strong trends across the US, and that makes sense because of our kind of gradient, depending on precipitation regimes of native or inherent pH levels. But certainly when we start to look at the relative change, and what this figure is showing, again, those same bins of soil pH and half a pH unit ranges, this is the average change in soil pH. There were about a little under 8 million samples collected in 2020. And this is the 2001 to 2020 number change. This is a relative frequency of change. So when you look at the y-axis and those percents, they're fairly low. But in general, we do see the trend of seeing more acid soils and soils that are not as frequently testing above 7.5 pH number, for example. And this is a 1-to-1 water equivalent here. Then when we kind of dive into the North Central region, this was a Crops and Soils article I put together a few years ago. We'll apologize for clicking there. But this is essentially looking at, again, PK, soil pH. There's also soil organic matter, but if we could just look at the red bracketed numbers, this is for North Central region states, again, 2001 to 2020 at the surveys. We really can't pick out a lot of trends for median pHs across the state, right? We know that soil acidity is this interaction between past management and inherent soil properties. And so looking at local issues is really where this needs to be most prevalent. And that's why accurate liming recommendations really have to dive into addressing the cropping systems and soil needs of the region that they're supposed to serve. There have been some previous works trying to summarize soil pH and buffer pH methods and liming recommendation methods across the US. This is a paper from 1983. It was summarizing a survey that was done at, I believe, the 1981 Limestone Conference. I think I still have the proceedings of that my major professor gave to me because I worked on liming for my master's. So one of the kind of few proceedings from a meeting that was very liming and ag limes focused. And when we look at the map across the US, we see buffer pH or liming recommendation methods. I called them lime requirement tests in the figure that were familiar, but probably not really in use as much anymore, right? We see the SMP method that may or may not be used depending on what state we're in. You see in Illinois, there was none offered because the buffer pH method wasn't adopted through the recommendations from University of Illinois. But again, tests, we see the Adams-Evans being prevalent in the Southeast US. And that kind of changes as we move up to the northeast. You'll see Vermont's kind of known for looking at salt pH and extractable aluminum, but not really surprising when we look at all this. And it's in context, this is pre-Socorro buffer solution area, right? One of the things that's interesting to me was when we think about the most updated or recent changes in soil testing and recommendations, really the adoption of the Socorro buffer solution for most states is the most recent change in what I'd say a new chemistry in soil testing. So it's kind of interesting to think about in regard to liming recommendations. And I'll show two kind of generalized figures that Bob Miller put together for a presentation. But essentially, we kind of understand just from working with both public and private soil testing labs that in general, we see this regionality between soil pH and buffer pH methods. When looking at the soil pH methods that we would expect to see as prevalent, we see 1-to-1 water soil pH methods being prevalent in the Midwest, some parts of the Northeast, and central US and South. But certainly we see calcium chloride salt pH being used in different parts of the country, the saturated paste method, depending on what state you're located in. Even looking at using KCl and then different ratios of a salt solution or water as well. That certainly is prevalent in some states because of most likely the recommendations or the laboratory methods that were supported there. When we kind of switch and look at the same map related to soil buffer pH methods, again, not really surprising that there is some regionality in general. The SMP method that was prevalent in the states that we saw in the previous map from the 1983 paper, most of those have switched over to Socorro and some states Socorro 2 in this case. But again, you kind of see that regionality that exists with buffer pH methods as well. Maybe a little more strongly cemented than the pH methods because of those. We look at a lot of names in these buffer pH methods. The scientists that were in certain regions really did a lot of research to support the need for using a specific buffer. So now we've kind of put a little bit of background. I want to spend a little bit of time looking at some of the objectives of the first LIME project, and then I'll get into the survey results and comparing the recommendations. So the LIME project itself really had a few major objectives. One was to just identify the status of pH and buffer method use and application around different states, to start to have kind of a collaborative discussion around liming recommendations. And again, just have a common knowledge level that we can all discuss. We see a lot of new faces in the soil fertility world, and so that's really exciting. And what this has done is allowed us to have a media to speak about and engage about different liming recommendation methods. But these are kind of some sequential steps to the first LIME project under the first umbrella as well. So now we'll kind of get into the meat and potatoes of what I'll talk about today and the recommendation survey. This is really, again, it was started by Bob Miller with ALP using ALP soils. The idea was that instead of sending a survey out saying what liming recommendation method do you use, what pH and buffer pH method do you use if you're using a buffer pH solution, buffering solution, we said, well, let's send out data for 6 specific soils and see what the recommendations come back with, so we can actually compare recommended liming rates. So we did that with 6 soils. They were submitted to 32 land grants and public labs that were associated with universities that were making liming recommendations. We asked them to provide a recommendation assuming 100% calcium carbonate equivalence, CCE or ENP, ENV, depending on what state terminology you use, that kind of changes. But essentially wanted to take lime quality out of the equation for this. The soils ranged from a water pH of just over 4 to 5.9, and the Socorro buffers range from about 5.9 to 6.9. And this is a little easier to see on a webinar than necessarily when we're doing an in-person presentation. So I threw this in here, but this is just the general soil properties that we saw with the soils used for the survey. So this table was sent out to the labs that were asked to respond to the survey. And so we can kind of see a different gradient in texture if you look down at the bottom, sand, silt, and clay percentages, different sea levels. So we would expect this to cover kind of a range of liming recommendations that we would see submitted by states. And again, a table I'm not expecting you to go through and read in, though I can glad to share it with you in depth. But these are the states that responded. In general, we had 6 states that that either didn't have recommendations or did not respond. But in general, it made a lot of sense. A lot of the states that either had multiple methods or responded with a liming recommendation were places that we found that we have acidic soils and that farmers are challenged with managing soil pH within their cropping systems. So I'll get into the data now from the survey and the recommendations submitted by the respondents of the survey. I'll have a few slides that are structured like this. And essentially it's a gradient of all the responses of liming recommendations. You'll see the state name on the x-axis. Sometimes a state will be listed twice if there are multiple methods in the state, multiple regions. Minnesota has 2 different liming recommendation regions, but that would be why a state is listed more than once. Or for the case of Delaware, there's multiple methods that are used in the recommendations. And you can see the liming recommendation in pounds per acre is on the y-axis, so divide by 2,000 for a ton per acre rate. I'll have a general summary of the soils in the upper right-hand corner, and then you'll see a mean and median, so kind of a bracket of where most of the average of the numbers lie. And you can see we see a really large range in liming recommendation numbers from different states. Not surprisingly, you see Wisconsin there at one of the largest, almost 12,000 pounds or over 6 tons of again 100% ECCE lime recommended for the specific soil. This was the soil with the lowest water pH and square buffer pH. A loamy sand that's poorly buffered, but still these are a very large range in liming recommendation methods. And when you start to look at the states on the x-axis, there may be some regionality here when we look at states that are similar in terms of where they are in the US. But really, it's kind of a toss-up. You see Wisconsin next to Maine, Minnesota, Mississippi, South Carolina. So regionality isn't really describing a lot of this general trend across the line here. And so we'll go through the results from the few different soils and kind of work through what the situations are. So we have a poorly buffered coarse soil. In this case, we go to a straight loam texture, still relatively poorly buffered with a low CEC, 4.23 water pH. I'll note when you flip back and forth, the y-axis does change on some of these, but I'll show all these soils together. So this was a relatively low buffer pH method for Socorro. And again, we kind of see similar states that tend to be on the ends of the spectrum here. And I think you'll see similar states that are within that median and mean values as well when we start to compare across the board, but still a pretty large range when we look across the states that responded here. We go into a little bit of finer textured soil and a silt loam soil, maybe a more comparable CEC to what we might find in a lot of Midwestern soils or soils in the north central region. And you kind of see a little change in the order there of the liming recommendations. See the Minnesota region 1 was a little more comparable Wisconsin in this soil. Then you have Kansas there, Oregon, Pennsylvania, and as we go down as well. And again, these are states that are all using largely different liming recommendation methods to come up with the final recommended rate number. We move to another silt loam soil. We kind of see a similar spread here. Again, similar states are in similar ends of the spectrum when we look at what their liming recommendation was. When we move to a little bit of an oddball soil with a sandy clay here and moderate CEC and soil organic matter, a little bit higher water pH method, we kind of see those recommended rates shrink down when you look at the y-axis here. But again, you're still seeing a pretty strong range of recommendations. And the final soil that I show was a finer textured soil, a little less, better buffered or less poorly buffered soil. But again, you kind of see that range is pretty large. Now in this soil, for example, we had respondents 3 states responded to the soil saying that they would not recommend a liming rate. And that was part of the responding data was, even though if you provided a liming recommendation rate, the recommendation might be 0. In a lot of those cases, there's kind of a threshold within those recommendations that kind of trips on that a 0 rate would be recommended. Some of those states, it's a buffer pH. For Maryland, they're looking at soil organic matter and texture. Arkansas is looking at Malic-3 calcium and some other parameters as well. And so this is kind of a take-home slide for the comparison of the recommendations, and we'll kind of keep it short and sweet, but it's a nice visual to see just the spread that we're dealing with, especially when we look at different states around the U.S. And Corey and I were talking before we started the webinar here. You'll notice that Illinois may or may not be on for some of the soils. And that was really just because of the lack of a buffer pH method that was adopted and used within the state. And so when we kind of look at this range here, we start to see, well, where's kind of the sense in that is the buffer pH method or the liming recommendation method causing this variability, or is it something else local that's probably making these numbers a little more separate when we compare them, right? We do see states that are recommending 0 lime applied in some cases. I know, for example, when you look at the soil on the bottom right, I did my master's at Iowa State working in liming and pH. I know when you look at the soil on the bottom right, that has a above 6.8 buffer pH, and so you would automatically kick that out as a 0 lime to be applied in that case. And you can see that again in the soil in the central part or bottom center part of the figure as well, where Iowa was at 0. Now, the question came again, what does the liming recommendation method or the buffer pH method, is that going to be, is one of them more variable than the other? And really, we kind of saw it scatter across the board. So this is essentially looking at those same 6 soils, the liming rate that was recommended on the y-axis. On the x-axis is the buffer pH, and NA is there for states that are not using a buffer pH. But essentially, this is kind of the spread of the points is the spread of the liming recommendations within the states that are using a similar buffer pH, not a similar calibration equation per se, but a similar chemistry or buffering solution. And with most of the states that were responding, we're using the Sikora buffering solution, but you still see a large spread. For example, in the bottom left soil, so the 1903 soil, you see that liming recommendation below 2,000 all the way up to over 8,000 pounds for this soil. And so even with the same buffering solution, we still see a wide range. So that kind of tells us that even though maybe some of the laboratory methods are similar and that the underlying concepts, most likely you're looking at a difference between either what was found from incubation or field calibrations for crop response, or excuse me, soil pH response to liming. And I'll get into a little bit in a few more slides about the difference between a target soil pH or liming for crop response. The last slide that I want to cover, summarizing some of the data, and again, this is just aren't really a relationship between the X and Y axis here or looking at the variables, but really, when you look at the buffer pH for each of those 6 soils, we can look at the CV or the coefficient of variation across those liming recommendations. So how much did they vary? And these are, you multiply these by 100 to get an actual percent, but these are pretty large variations. And we saw that within the bar graphs that we recently showed here on the slides. The interesting thing here, and most likely the variation across liming recommendations was pretty consistent across all of the soils and all the states, because like I pointed out, when you get to a pH 6.5, 6.8, 6.9, some of those states will have that threshold that click off their liming recommendations, whether that's in the software that's used in soil testing labs or just part of their recommendation philosophy and method. And so those range of recommendation responses, then we did see an increase in variation as the buffer pH got larger, but it's really a few states dropping off and saying that there's no lime applied. And so there's a little fewer respondents of states that you would recommend lime application. Now, certainly, let's talk about a few of the implications of the variability of data that we're dealing with here. So I just chose one soil. This was the first soil that we looked at, the poorly buffered loamy sand soil. when you, and again, I just used a $34 per ton cost. But when you look at the lime cost, and then this was product and application cost, we'll assume that we're using a 65% CCE ag lime. And so essentially you take the liming rate that was recommended for 100%, you divide by 65, and then you multiply by the cost. And this is just kind of a frequency or a histogram or number of states that would be in those kind of bins of cost to the farmer if they were recommending lime for this specific soil. So you can see that a lot of states were kind of within that $75 to $150 per acre cost. There were certainly some closer to 200, but a really wide range. And when trying to predict some type of, I think liming isn't necessarily, it is a variable cost, but you can kind of plan for it depending on your soil testing strategy over however many years or time you're focusing on that versus when you're predicting you're going to probably have to make a lime application. These certainly are ranges of costs that would make us want to kind of look at why those recommendations were so variable and how that's also affecting farm economics. Certainly something that's important to consider. On the agronomic or kind of practical side, not to hop into some data slides, but this is from a long-term response to target soil pH study that I've worked on up here in Wisconsin. It was started by John Peters, who was the director of the UW soil testing lab a little while ago. But essentially looking at, there's a study that we're managing plots and treatments for certain target pHs, ranging from 4.6 all the way up to almost 6.8 or 6.6 really. But essentially, when we see these responses, it's really hard to find a crop response to liming once we start to get above that target, a pH, soil pH, or in this case, target pH of 5.5. And I've noticed that from my liming work when I was in Iowa as well during my master's, when looking at kind of field responses or strip trial responses to liming. It's not always clear that we're getting that crop response. And so that's why the target soil pH is a focus here. But that does change within our states. And some states in the Southeast, they're actually focusing on a crop response to reducing aluminum toxicity or aluminum solubility. And so that is a true crop response to liming, where we're really looking at the soil response to liming. So that's a different philosophy that exists within all these states and is important to consider as well. And within the study, from the data that you're seeing on the slide here, these are those those soils that range from essentially from a measured pH of 4.2 up to about 4.8, 4.9. You can see with the trees in the background, this is the same plots looking at corn and soybean lack of production or yield because of those low pH areas. So we know agronomically and practically that we do see limited growth in yield and production and profitability because of extremely low pHs. But again, it's always hard when we start to get up towards that 5.5 to 6.5 range, because generally we're not seeing those crop responses that we would expect within extreme situations like this. And then there's this practical implications, which are probably the most important, of when we see responses of soil pH or crop yield to liming. There's liming and management and soil interactions and combinations that make it really hard to predict what your ROI on liming is. And depending on what cropping systems are prevalent, that's going to change as well. For example, I can tell you that we saw those really high Wisconsin recommended rates of ag lime. But I know the philosophy and some of the previous work that was done in here decades ago on liming recommendations is an assumption that all cropping systems always had alfalfa in their rotation in Wisconsin. And so that optimum pH for alfalfa was considered in that field calibration. And so there's things like that, little nuances that exist regionally that are really important to consider, though. We can't just throw those out and say, we're going to just make one recommendation without considering local cropping systems, soils, and on-farm economics as well. And so the kind of, again, this data here is from a study that I had different liming rates applied either in a single application or annually split out throughout 4 years. This is just the first year of the data for this study. And then it was for a tilled and no tilled system as well. And two different sites, you see very different soils in terms of their buffering capacity. And we saw different responses in the upper 2 inches of soil pH2 liming from the fall of 21 to the spring of 22. So this just is kind of a nice example of that. We do have this interaction between our liming rates we're applying, when we're applying it, tillage systems, and then inherent soil properties as well. So even though we're kind of looking at these liming recommendation survey results and saying, wow, this is crazy how variable it is, we really have to take this into context of local cropping systems and just the science that was done to support it as well. And then we didn't even really touch the lime quality aspect, that we have to really consider the comparison of chemical and physical properties of our liming materials to what we're putting out there, and how quickly we expect those soil pHs to respond, or crops to respond in some cases. So a survey of, or excuse me, a summary of the survey that we've done, and there'll be an up and coming peer-reviewed paper describing this, but I think the kind of fact sheets that we'll put out are pretty useful in here, and that we certainly saw a wide range in liming recommendations. States that tended to be above or below that median or mean were usually consistently above it. One thing that it's important to consider is, and we sent out the same data for 6 soils to every state that we could get a hold of. One thing that's important is whether those soils are really represented in the major crop production areas of the state, and if they matter in terms of where that state's making a lime recommendation. If you're in a state that doesn't deal with sandy soils at all, or maybe has a small pocket that isn't largely represented in crop production acres, it's really hard to validate doing a lot of research on that. And so that's something to consider as well when we look across the US in general, but again, locally as well. So those dominant soils that were used to create the recommendations might explain some of it. And I talked about how different cropping system assumptions are really important as well. So I'll kind of go into, we kind of walked through the survey, and at the end, I'd certainly can flip back and go through any of the data, but I want to just review some of the next phases of what this work is kind of teeing up. So within the first Lyme committee, led by Dr. Amy Schober at University of Delaware, we're moving to a next phase that we'll be looking at doing a Lyme calibration incubation study, looking at soils across the US. The goal was 120. There's 106 collected as of our Lyme committee meeting yesterday, actually. So that's really exciting. And the next steps will be to look at soil pH response to liming, different lime rates across all of those soils. And so all those soils are collected. Dr. Bob Miller has collected all those at his location in Colorado, and we'll be working on kind of the logistics of getting those analyzed. But we'll be looking at different pH and buffer pH methods that will be run on these soils: exchangeable acidity, exchangeable aluminum, and then kind of general fertility tests as well, looking at soil organic matter. We might look at different carbon dynamics, but I think that might be kind of a next step within that work. But essentially, we'll go through and do kind of an exhaustive analysis of soils before doing the incubation. Through the incubation, we'll be measuring soil moisture. And I know I did a lime incubation for my master's work, and there's a lot of things that go into the protocols for these, because they don't necessarily represent field conditions exactly. And so we're trying to keep things standardized to at least compare these soils across the board. Looking at nitrate and ammonium levels throughout the incubation, and trying to use that as a proxy for mineralization, whether it's because it would be an aerobic incubation is really important. So all of these things are kind of getting planned out. That will be part of the next phase of this liming work through first. There will be a pilot study that we're looking at using different lime sources, so comparing calcium hydroxide to calcium carbonate, to try to understand if we can use a little bit of shorter timeline on incubations using calcium hydroxide. And we're kind of working through that decision right now within the first Lyme committee. With that, I'd like to leave plenty of time for questions and some back and forth dialogue. These are all the survey collaborators, and there probably are some other people that got information together that that were necessary that I didn't catch their email, or they weren't in the email chains. But it was really a great group to work with. This was a nice data set to kind of as a call to action to say, hey, let's start working on specific states Lyme recommendations that we can try to kind of get to the next step to serve agronomists and growers in that regards. So with that, Corey, I'll stop sharing here, but I can certainly pop back to any of the screens to answer questions as we go forward from here.
Yeah, so first off, I very much appreciate that, Dr. Jones. That was I wrote down like 10 questions actually that I'm excited to hear your opinion of, or your answers to. I just want to I'm going to go through a little bit of information about Alta. While I'm doing that, I invite people to put questions in the chat, and we're going to have a great discussion at the end of the conversation. The first thing I just want to share is that if you are interested in diving deeper into the soil testing world, the agricultural testing world, Alta does have an in-person summer workshop in Bloomington, Illinois this year. You can hit the QR code there to learn more. And anyone who registered for this meeting, I'm going to send out some information about that meeting as well. So that's at the end of August. It's going to be a great in-person workshop. Dr. Jones is presenting, as well as some people from across the kind of across the US, to be honest with you. So it'll be a great mix. A couple things I want to highlight. The conference is sponsored by, we have two big sponsors, our Alta workshop sponsors, Agilent, which if you're not familiar with the soil testing world, Agilent is one of the top ICP manufacturers. So ICPs in our labs are the primary soil fertility workhorse. And so they're doing a lot of your nutrient testing on soil fertility samples across the US. And then our other Alta workshop partner is Precision Planting. A lot of us on the call are probably very familiar with Precision. They have a new radical agronomics program that we're going to actually we were actually invited. We're going to go at the second day of the workshop to their facility in Tremont, Illinois, and do a tour and get to talk to them about this new program. It's a very exciting opportunity. Additionally, we have several other sponsors that I love to highlight. The other thing I want to share is there are CEUs available for today's talk. I would love for you to use the QR code here, and you are welcome to self-report your CEUs. Otherwise, you can send me an email and I'll make sure you get those CEUs. So with that, Dr. Jones, let's transition to some questions. Here, let's answer this first one right off. Can we share your presentation?
Yes, yeah, I'll share the slides with Corey, or if anyone has any specific questions, they can always just email me.
And also, I will just highlight that this webinar and the discussion afterwards will all go onto our Alta YouTube channel with all our other previous presentations. So that will be a great opportunity for additional questions. So I do have questions, but I'm seeing some come in the chat. So let's go to those people. First question, what depth were soils used for the different survey collected? Do states differ in the depth of soil sampling for liming recommendations? And could that have influenced variations in rec?
Sure, that's a good question. And I think I had it on the slide, but didn't mention it. We asked that all the respondents assume a 0 to 6 inch incorporation depth. So that's kind of the first question. Yes, so we did have a standard 6-inch incorporation depth. States do have differing depths. Certainly there's different soil testing depths or probe collected sample depths that are recommended by different states around the U.S. And there was a survey done within FIRST a little bit earlier, led by John Spargo and Sarah Lyons, that did publish on that. And so that's part of the consideration for different liming recommendations regarding soil depths. Some states are working with the exact soil depth that the sample was taken. Some are assuming most do assume some type of incorporation depth, whether it's 6, 7, or 8 inches. Many states do have a adjustment to liming rates, recommended rates for no-till systems. whether that's an assumed even though there are no-till systems, they're assuming the incorporation of the lime, not necessarily through tillage, but through precipitation and freeze thaws is more like 2 or 3 inch depth. Also, that may change. I know, for example, Iowa had different recommendations for pastures that were more similar to no-till situations. So certainly that influences the recommendations, but in the survey data that we looked at here, we asked that they consider only a 6-inch depth and a 6.5 target pH as well.
Yeah, that's a great question. And also, I know that there is a presentation on soil sampling depth, and I'll try to find that and send that out to the group. Second question, I wrote this down too. You used the term ag lime. I know you described it as 65% CCE, but is there an official definition of ag lime? I have worked in several states and have never encountered one. I think that's a really good question. So thank you for asking.
Yeah, that's great. And I remember digging into this for my master's work. So the Soil Science Society of America glossary does have a definition for ag lime. So that's when writing peer review papers, that's pretty common to refer to that. And usually I don't remember the exact verbiage off the top of my head, but usually it's considering some type of material that's either affecting pH or aluminum toxicity as well. Both of those are actually soil pH and aluminum toxicity or solubility are within that definition. One thing that's important, and we didn't really touch on lime products and lime quality here, but there are very different definitions between different types of liming of lime itself. And I think that does come into play when looking at kind of what's available locally. In general, calcitic lime has a higher portion of calcium carbonate. There may still be magnesium carbonate in calcitic lime. I believe the Soil Science Society defines dolomitic lime as anything higher than 12% magnesium or magnesium carbonate that is present. So that's a good definition. That's really important. I'm defining ag lime as something that would be quarried and ground, maybe sieved, that would be sold to farmers or agronomists or producers. I know there's certainly different definitions for, and Corey just threw the link to the glossary in the chat. There's definite definitions for pelleted lime or pelletized lime. Sometimes those terms are used interchangeably as well. But in general, anything that's affecting soil pH or aluminum toxicity in this case.
So I'm going to encourage people to put questions in the chat, raise your hand, and I'm happy to call on you and we can have discussion. While people are kind of thinking through that, I have some questions I'm going to walk through. And the first question that I love to ask anyone who says they know stuff about pH is to define, and this is a question I get with growers all the time. What is the difference between water pH and buffer pH?
Sure. So kind of the off the cuff answer I would usually give when talking about water pH and buffer pH is essentially you're mixing soil and water and using an ion selective probe to measure hydrogen concentration hydrogen activity in solution, not necessarily concentration. But essentially the difference and you may use a salt solution. So we saw some states use calcium chloride, some use potassium chloride as well. But then for a buffer pH, essentially that solution is buffered at a specific pH. And then when you're adding the soil to that solution, that pH is dropping of the measured buffer. And the amount of drop essentially of the buffer pH value is positively correlated to the buffering capacity for changes in soil pH. So when I talked about having a buffer pH of 6.9 and states not recommending liming, that's because that pH did not drop very much from when the soil was added. And that soil does not, that soil can buffer pH, buffer changes buffer changes in soil pH. If that pH would have dropped to 6.3 or 6.4, that's a different scenario of where you're most likely going to be applying lime.
So, kind of a follow-up question, just following this thought pattern. One thing that always comes out to me when I hear the first group speak, and definitely this presentation really calls it out, is there's huge discrepancy between states on what the recommendations are, how you interpret that information. And I guess one question I have is, if I'm a farmer in any individual state, how should I feel about that? I mean, should I be thinking I need to go, I'm on the Wisconsin border of Illinois, so I should be using Wisconsin's recs instead of University of Illinois' recs? How should we as advisors to farmers or farmers on the call, how should they be thinking about that?
Sure. Well, I think one of the most important things about any recommendation, if you're dealing with phosphorus, potassium, lime, and I mentioned this a few times in the presentation, is getting a really good understanding for what the supporting research is for that recommendation, what soils and what cropping systems as well. For example, in Wisconsin, it's pretty common knowledge that in our very coarse sandy soils, the equations for a liming recommendation in the state may come up with negative values, because a lot of research was not done on some of those really sandy, poorly buffered soils for the liming recommendations. And so within that, there's a minimum lime kind of rule within the recommendation that goes to 1 ton per acre. And essentially that's because the supporting research didn't have enough coarse soils within it. So if I'm a farmer agronomist and looking at state-based recommendations, understanding the scientists that develop them, but also what soils they're intended to support is really important. And so that describes some of the discrepancies across state lines. Again, those cropping system specific considerations are really important. Like I talked about, that alfalfa rule in Wisconsin was one of the things that when looking at phosphorus and potassium across the board, there's certainly some changes, even though the North Central region is a little more similar than not when you start looking across the U.S. and the variability across the whole U.S. But I think that's one of the challenges, but also opportunities, and certainly I see it as a young faculty member and working in Illinois, is now we have the ability to really dive in with some great collaborations and partners around the state, dive in and start creating some databases that can show that there's a lot of rigor and science behind those recommendations. So there's challenges, but there's also some really good opportunities. If you're a farmer or grower, it's really important to reach out and just have a few conversations about what are the details behind the recommendations. There's a lot of meat sometimes in, for example, the Illinois Agronomy Handbook, different recommendation documents. That's really important information because we all have to take all of these numbers into context of how they were developed, and that's really important.
Okay, so I have a kind of a series of questions that, oh, wait, hold on. We have a question in the chat. Let's go ahead and jump to that. Why do some soils with tested soil pH near neutral, but still have lime recommendations? Is it necessary to lime if soils are not acidic? It's an interesting question. Do you want to?
Yeah, so there weren't any soils in our database that would be considered alkaline or not acidic. And so we didn't show any information of that today. In general, I talked about how target pH is really what determines liming recommendations in most states. And so if your target pH is 6.5 or 6.8 for legumes in some states, specifically alfalfa, that then if you do have a 6 to 6.5 pH, and again, that's still acidic, there would be a liming recommendation. Now, one thing that the individual asking the question is, if you're talking about the buffer pH, remember that can be is almost at 7, and technically liming would still increase that soil pH or the water or salt pH. So remember, the buffer pH is just essentially the change or buffering capacity of that soil to handle different acidification or liming processes. I think it would be not very common for a non-acidic soil to have a liming recommendation. Now in some different parts of the country where calcium nutrition might be a little more important, such as in tree crops or fruits, there might be a non-liming reason for applying something with some calcium or calcium carbonate, but most likely in those cases, they're not using lime as the calcium source. They're using some type of soluble fertilizer. So in general, I would not expect to see a liming recommendation for a non-acidic soil, and certainly it wouldn't be profitable.
Okay, so with the discrepancy in liming rates, do we see the same discrepancy in liming frequency from state to state? The best thing to do is retest. But if I put 6 tons of lime on in Wisconsin and 3 tons on in Iowa, assuming the same soil test values like you showed in the graphs today, I assume the frequency is going to be different.
So just to confirm, you're talking about what would be the recommended frequency of application. In general, I don't think many of the states have a frequency of lime application recommendation. They're really basing any lime recommendation off of a frequency of soil testing. And certainly some states have their own ideal soil testing intervals that you're gonna work through. Ideally, if we can catch between 2 to 4 years, usually we're getting within that rotation at least once, maybe twice, that we can pick up any changes in soil nutrient levels or soil pH. Now I will say there are cases where if your pH is really low enough, 4.8 or something like that, and let's say there's an 8-ton liming rate that would be recommended to get to where you need to be, you probably should consider making two steps to that, 2 to maybe even 3 steps to that. Depending on what tillage operation you're working on, if you're not going to be incorporating that. I worked with a farmer last fall that knew he was going to be putting wheat in, had soil tested for the first time in a long time, and had some really acidic soils, soil pH levels. And so we got 2 tons of lime out there immediately and incorporated it before the wheat was planted, just because we knew there was going to be significant yield reductions in the wheat. Come back in the summer after the wheat was taken off, and then the rest of the liming rate will be applied there. So certainly there's some flexibility, and I think that's really important. However, I will say, talk about the frequency, and I've got some data on this because of a certain study that I had this question. I really think it's important to get that soil pH fixed up front. Kind of dribbling low liming rates may work in some cases, but in a lot of cases, we really want to get that pH fixed as soon as it makes sense for your pocketbook to do so. That's really important. I've worked on some studies where we're looking at low liming rates of either ag lime or pelleted lime, and really the liming rate overall is going to be the most important to affect that pH change.
So
I hope that answered your question here.
No, I think that was great, and I'm just going to offer a couple comments. One thing that I always think about when I think about fertility and frequency of application is not just what is needed based on the soil test value, but what are some practical limitations? Like if I put over 2 tons of lime down, is a lot of that going to run off? Is a lot of that going to get lost? Can the equipment in the field actually do that application? So there are some other factors there that I always encourage people to consider.
And certainly one thing that is important to think about, depending on your lime quality, is how fast that lime is going to react. So getting it out in the fall, even if you're not putting a full rate, that may be recommended to get your pH to 6.2, 6.5. That could really benefit you in the long term. But think of it as a long-term investment. And we say long-term, 3 to 4 years, the pH can change quite a bit within 2 rotation or 3 rotation cycles. But it certainly is an investment that is, multi-year.
Yeah, and I think one thing that is important to highlight is when I talk to farmers, one of the biggest value that they get from their soil test results is their pH and their lime recommendation. So you can't overthink about this. That's what I always like to tell people. You think about your strategy, think about your approach with liming. I think that's really important. because this is probably the single most important nutrient, or it's not a nutrient, but data point that you get off of your soil test recommendations and your soil test results. So Steve, you asked a great question. Have you looked at how the states use the buffer pH to estimate exchangeable H and calculating the CEC? So
Yeah.
go ahead.
Oh no, I was gonna say I'm familiar with doing that because that is in the North Central recommended methods. We do use either SMP or Socorro buffer pH. They, really should be part of that summation of CEC estimation. Although they're not always used. Similar to sodium is not always used, depending on what even though we don't have appreciable amounts of sodium within some of our North Central soils. So I've looked into that a little bit I'm familiar with the calculations and how we use buffer pH to estimate exchangeable hydrogen specifically in this case. Usually when I've worked with some data sets where you have buffer pH ran and we do actually measure exchangeable acidity, whether it's looking at hydrogen or aluminum in some cases, there's a nice relationship. I think in our soils in the North Central region, that buffer pH component of the CEC calculation is not as important as when you start to get into different parts of the country. And so that's usually why it's left off. But I can tell you for peer-reviewed publications that I've published, we use in that case the Socorro buffer value, and that's and we can share. I don't know, Corey, if you can share the document, the North Central methods document that has that calculation in there, and it might have some supporting research for that. I don't know. I'd have to look at that.
So I will, that's a great call out. I will share a link in the email to several of the methods. One, I just want to make a clarifying point for people who are maybe less familiar with the soil testing industry. But when we get a soil test report as a farmer or a consultant, you get a value that's labeled CEC, and you get a values labeled base sats and these kind of things. And one thing that's maybe not broadly understood is that many labs are not directly measuring CEC of the soil. They're taking like I mentioned earlier, their ICP data, their pH data, and they're kind of back calculating what that CEC value should be. And so that's different than directly measuring the soil. And that's being done for expediency in the lab and several other reasons. It's an accurate thing to do. It's, as you mentioned, it's an approved process in the North Central region for sure. But sometimes people don't realize that on our soil test reports, there are these calculated values and these actual tested values. And sometimes there's a discrepancy there, and it's good to understand that. Before we move to the next question, I did kind of want to hit a little bit of a follow-up on that, which is, or maybe it's a follow-up on the last series of questions, but from your perspective, what do you think needs to be done next when it comes to soil test pH? And the reason our buffer pH or liming recommendations, and the reason I'm kind of answering that is you put out 2 steps in the presentation. We do an incubation study. But my thought process is, should the recommendations be regional? Because there are factors like weather and things like that are very specific to that region that mean that I don't know that the lime recommendation for Wisconsin, even if all the soil test values are the same, if the lime recommendation in Wisconsin should be the same as the lime recommendation in Southern Illinois for a lot of factors. So what is the next step? Do we need to, we had SMP buffer. That's been greatly replaced by Socorro buffer. A lot of times that's for practicality reasons in the lab. They're relatively the same test value. But do we need a new buffer pH test? Do we need to review our target pHs by state? Like, can you comment on that thought a little bit?
Sure. So I think one of the things that some labs are already transitioning to is looking at using salt pH instead of water pH. Anyone who's worked with soil pH data on-farm research in your garden. It's variable. It's going to depend on incident soil moisture when you're sampling. There's a lot of fluctuation temporally across the same soil, even if you have the same research plot. And there is some ability to lessen that fluctuation with a salt solution instead of using double deionized water, because you can buffer against any salts that would essentially be within that soil. And we're not talking about salines soils in this case, just because of the inherent water content of a soil. When you sample it, that salt concentration may change. The salts may be there and you didn't get a lot of rain. And we're not talking about harmful salts that are affecting crop production. We're not talking about saltwater intrusion on the East Coast. We're just talking about ions that are in the soil. And so salt pH or calcium chloride might have the ability to lessen that fluctuation. There's a little bit more research to confirm that could be easily worked into everything, but I know soil testing labs are working with that already. So that's, I think, part of a step in comparing methods around the North Central region and different states as well. I would say one of the most important things to me, and I'm a big fan of field calibration of any nutrient recommendation. I've done a lot of that for P and K as well. We need, when we do incubation studies and we're looking at soil pH changes given a lime rate that's applied, there's relatively little acidification sources or forces that are happening on that equilibrium of that soil. And that's really important, because let's say we're applying lime in the fall. We have different freeze thaw events, we have different tillage events, soil temperature and moisture fluctuations, where you have different microbial biomass growth and decay. Nitrogen fertilizer is applied. We might be removing base cations and residue. We're leaching things through the soil. What we see in the field is very different to what an incubation is going to tell us to do. And so I think there really needs to be field validation of any liming recommendations that are going to be made. And then you have to take into consideration just the system components, the tillage, the cropping systems and crops that are going to be planted, the lime product that's going to be applied. All of that is really important. So I think that's going to be part of where you kind of hone into a liming recommendation. But I think your point, Corey, is important earlier, is not to overthink it either. In general, we know pH is variable enough that if you're consistently testing above 5.8, 6.2, you're probably not going to see a big crop response to liming. But if your target pH is 6 to 6.5, then that's where you might want to move to. I think that's important. I feel strongly that we need to have representative soils in the regions that recommendations are going to be made to. So it's really important to get not only whether it's incubation work, but then also field work that's representative of the area. Because even if a soil has the same soil pH and buffer pH, there may be some different ionic chemistries that affect whether a lime soil pH is going to respond or a crop's going to respond to lime. Sorry, a little bit of a long-winded answer.
No, I think that was a good answer. I think that you kind of covered part of the next question, but I'm gonna go ahead and read it and maybe you can address Blake's question directly. Do you feel that it is important to get states on the same page with shared standards for lime recommendations and soil pH testing? If so, can shared standards and interpretation be simple enough to facilitate affordable testing, but robust enough to capture local variation? So Blake, I didn't actually read your question, but I think it kind of overlaps with where I was going anyway. But Dr. Jones, do you want to kind of
respond directly? That's a great question, Blake, because I think there's and a lot of times we're in soil fertility research and in general in agronomic science, we're heading towards a lot of big data approaches, right? But we're heading towards, large data, maybe some regional interpretations of things, but we have to dial into what's happening in the field on a very finite scale. So those are two things that really need to be balanced. And in that case, I think what makes sense is to work with states around you to provide farmers and agronomists that are working on similar soils in your area. For example, I work with Dr. Dan Kaiser at University of Minnesota, where you know, he was working on some liming and sandy soils. I was considering that as well, working together on making sure that that we have kind of some consistent recommendations and interpretation on that. I would say there's a benefit not only to having more consistent interpretation, but just also when you're collaborating across states and you can get more resources, the science can really benefit from that as well, supporting science behind it. Shared standards, if you're talking about laboratory methods that are used, I think the private soil testing lab has already actually done that really well, maybe compared to the land grant recommendations, I would say, and just talking about soil pH and liming. What may be the default answer to the survey for the land grant soil testing lab or person working on the recommendations might be a little different than what the commercial lab serving a lot of farmers and agronomists in that state are doing. So I actually think working with private labs to make sure that we're meeting all the consistency that's available is important. One of the things that's really the most important is just to have field validated recommendations for any test that's going to be used in interpretation. We see that on the P and K side more, whether there's a P test or a K test that's being run that maybe that state doesn't have an interpretation for. That's kind of on the onus of the state to step up and say, let's provide a recommendation for our farmers in that case. I did that here in Wisconsin for different P and K tests, providing more interpretation, and I think that's just kind of part of Extension serving the farmers and growers within that state. But I think it does facilitate a pretty easy interpretation across state lines, and you can still capture local variation. Certainly when you're putting together big collaborations where you can get more soils represented in the research, that's really important as well, and that helps everyone. But great point, Blake.
So I know we're at the kind of where we're past the top of the hour, I guess is what I'd say. But I have a few more follow-up questions. I do want to remind everyone, we will share out the webinar. So if people have to drop off, there will be an opportunity to watch those discussion afterwards. That said, one follow-up question I did have, or maybe it's not a follow-up question. One question I would love to get your thoughts on is, we know as an industry that soil pH is really important. I'll caveat this. This is a basic, like really soil science-y question. But I think as the industry, we know that liming is important, maintaining soil pH is important. But could you give kind of an intro to soil science answer to what becomes limiting at low pH that's limiting maybe our crop response in corn and soybeans, and what becomes limiting at high pH? So maybe where is that at? And then what nutrients are we actually preventing the crop from getting? Why is it limiting those yields? Can you share a little bit about that?
Sure. So we can kind of start with the low pH scenario or acidic soil scenario that we talk about most of the case when we're looking at liming. So in general, when we think about things that are, and you said things that are limiting or not available, but I would first start with things that are very soluble or available to plants at low pH that are harmful. So when we look at things like aluminum solubility is higher at lower pHs. And so in general, in soils where there is enough extractable aluminum and it is soluble, you can have usually some type of root damage or root growth restriction because of that. Now, what's important when thinking about nutrients like iron, but we're not really thinking it as a nutrient per se, right? In this case, is that iron and aluminum are working when they're in a low pH to split water and actually make the environment a little bit more acidic as well. So there's kind of a snowball effect when you start to get to low pH environments that are really hard to overcome. So interestingly enough, there's been some research recently, I shouldn't say research, there's been some summaries recently published out of the soils department here at UW. I wasn't involved with it, but looking at kind of critiquing that nutrient availability by soil pH diagram. So that one of those renditions originally came out of came from Emil Truog at UW-Madison, and I think what's important is that's really conceptual when you think about nutrient availability, but it really holds true when you look at kind of the chemistry of how those nutrients interact at different pH ranges. We know that phosphorus solubility is not necessarily P solubility, but P availability in relation to iron and aluminum is lessened. When we get to low pHs, essentially you have more soluble iron and aluminum that can bond with the P. And then when you get to a high pH situation, you usually have calcium that can actually start to bond with the P as well, because the iron and aluminum solubility is much lower. And in general, when you look at one of the things that it's not a direct availability effect, but at low pHs you can have a lower cation exchange capacity if those soils have pH dependent charges. So the soil's ability to retain nutrients can be lessened at a lower pH value because of the charge that's on those soil surfaces. And that's usually in relation to iron and aluminum oxide, clays, and soil organic matter. And so that's something that's really important when moving to high pH soils in general. People get concerned about micronutrient availability, specifically zinc in most cases, and I've seen instances, for example, sorghum production in the high plains in Kansas, for example, deals with zinc deficiencies because of those high pHs and the solubility. So a lot of those pH effects on nutrients are due to the solubility of the nutrients, whether it's going to be precipitated or in the soil solution. And it's not always a direct effect on nutrient uptake. One thing that we haven't really talked about, kind of been talking about physical and physical chemistry and inorganic chemistry, but certainly soil pH has a large impact on kind of optimal soil microbe functioning relating to nitrogen cycling and sulfur cycling as well.
So thank you, that was great. So just to kind of wrap up, one thing that's really I'm excited about as someone who's based in Illinois is that you have moved here to become our soil fertility expert in the state of Illinois, which is a much needed role at U of I. And so I want to kind of end our webinar today with maybe you can share a little bit about your perspectives on what is needed in the soil fertility world in Illinois, and maybe on top of that or along with that, some research directions that you want to go first with those kind of conversations.
Sure. Just to confirm, Corey, do you want just liming and pH? Or, okay.
I'm happy to hear about anything.
All right. No, I think one of the most important things for me is addressing fertility challenges that growers are having to deal with. And so certainly, when we think about, a priority of nutrients working, in involving some type of, I certainly am excited to work on core nitrogen recommendations and management in terms of making sure that we kind of work with all the scientists that have been in play and kind of move logically towards what makes sense for local solutions for nitrogen management. That's going to be something that I'm really excited to focus on, especially dealing with different loss pathways, but then also how we can essentially try to use different proxies to plan out what a nitrogen management strategy might look like for a given cropping system and cropping year. I do have a lot of background in soil tests, calibration, correlation and calibration and field calibration. I was luckily involved in some recommendation building in Iowa and Wisconsin as well. So what I'm also excited to work with the ongoing work that Dr. Margonaut's leading as well, looking at phosphorus and potassium recommendations. I think that's something that I've had a lot of experience in and I really, really enjoy working in. We've already kind of started the ball rolling on looking into liming recommendations and putting something in place that would make sense for Illinois and what kind of the soil testing labs also serving Illinois farmers in that regard. So I think what the overall, if I can just kind of summarize what my objective is, I think we've measured soil nutrients really well in different boxes in a traditional textbook diagram of a nutrient cycle, but we don't measure we don't know the arrows very well between those boxes. And so that's something that I'm really excited to get into, is the flux of nutrients and trying to see how we can not only understand the science behind it, but make just really practical solutions that are actionable for farmers. That's something that I'm really excited Certainly we'll throw it out there. You know, I know Corey shared my email, call, text. I'm excited to get around the state and really work with growers and agronomists.
Well, that was a great response. I really appreciate that. Seeing no other questions coming up, I am gonna go ahead and say that I'm gonna go ahead and stop recording and say we're done with the webinar. And I appreciate everyone who was able to join us today. Again, I encourage you as we go about our day to send Dr. Jones an email directly, and I'm sure he'll be happy to answer any questions.